Hey all, this is Kalpana here. In this video, we're going to solve a problem from differential equations. So let's get going. Problem. Given equation x square plus 3xy into dx plus ax square plus 4y into dy equal to 0, determine the constant a such that the equation is exact and solve the resulting exact equation. So here we are asked to find a, assuming that the equation is exact. Okay. Later, after finding a, we'll substitute this a in this equation and we'll find the solution to the problem. Okay. Given differential equation, x square plus 3xy into dx plus ax square plus 4y into dy equal to 0 considered as equation number 1, which is of the form Mdx plus Ndy equal to 0, right? Where a equal to x square plus 3xy, m equal to x square plus 3xy and n equal to ax square plus 4y. So here assume that one is exact, right? Then partial derivative of m with respect to y equal to partial derivative of n with respect to x, right? So dou by dou y of m, that is x square plus 3xy equal to dou by dou x of n, that is ax square plus 4y. This becomes dou by dou y of first term plus dou by dou y of second term equal to dou by dou x of first term plus dou by dou x of second term. In LHS part, we'll do partial derivative, partial differentiation with respect to y. So here x is treated as constant. So in the first term of LHS, x square is constant. In the second term of LHS, 3x is constant, right? So we'll write this as dou by dou y of x square plus 3x into dou by dou y of y, right? Equal to, here a is treated as constant. Let's write a into dou by dou x of x square plus, here getting partial derivative with respect to x, right? So y is treated as constant. Obviously 4y is constant, so we can just write this as it is. Partial derivative for constant with respect to y is 0 plus 3x into partial derivative of y with respect to y is 1 equal to a into partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0, right? This gives us 3x equals to 2ax, or we can write this as 2ax equal to 3x. Now take this 2x to RHS, then we'll get a equal to 3x by 2x, where a gets cancelled and you'll get a equal to 3 by 2, right? Now we got a. Let's substitute a in the given differential equation or equation 1. 1 becomes x square plus 3xy into dx plus a, replace a by 3 by 2, 3 by 2 x square plus 4y into dy equal to 0. Consider it as equation 2. Now let's check whether the resulting equation, that is equation 2, is exact or not. This is also of the form Mdx plus Ndy equal to 0, right? Where M is x square plus 3xy and N is 3 by 2 x square plus 4y. We know that when partial derivative of m with respect to y equal to partial derivative of n with respect to x, equation 2 is exact, right? Let's now find partial derivative of m with respect to y and partial derivative of n with respect to x. I'll begin with partial derivative of m with respect to y is equals to dou by dou y of m x square plus 3xy. Since it is partial derivative with respect to y, so x is treated as constant. Here x square is constant, in the second term 3x is constant, right? We'll write it as partial derivative of x square plus partial derivative of 3xy is equals to partial derivative of constant with respect to y is 0 plus constant 3x into partial derivative of y with respect to y. This gives us 3x into partial derivative of y with respect to y is 1, which is 3x. Let's now find partial derivative of n with respect to x. Dou by dou x of n, 3 by 2 x square plus 4y. You can write this as dou by dou x of first term plus dou by dou x of second term. Since it is partial derivative with respect to x, so y is treated as constant. Here 4y is constant, here 3 by 2 is constant, so we can write this as 3 by 2 into partial derivative of x square with respect to x plus partial derivative of a constant with respect to x is 0. We'll get 3 by 2 into partial derivative of x square with respect to x is 2x, where 2 gets cancelled and we'll get 3x. So by observing these two, we can say that partial derivative of m with respect to y equal to partial derivative of n with respect to x. Therefore, partial derivative of m with respect to y equal to partial derivative of n with respect to x equal to 3x. This shows that equation 2 is exact, right? Now, let's solve this equation. We need to find the general solution here. The general solution is given by integral Mdx treating y as constant plus integral terms of n free from x into dy equal to c. Let's now find integrals separately for our convenience. Integral Mdx treating y as constant. We have m x square plus 3xy into dx. We can write this as integral x square dx plus integral. See here y is constant, so in the second term 3y is constant, so we can write this as 3y into integral x dx, right? This equals to integral x square dx is x cube by 3 plus 3y into integral x dx is x square by 2, right? Here 6 is your LCM. The denominator of first term you are having 3, so close 3. And multiply this 2 to the numerator of first term, you will get 2x cube. And in the denominator of second term, you are having 2, so close 2 and multiply this 3 to the numerator of second term, you will get 3 times 3x square y, which gives us 2x cube plus 3 3 is 9 x square y by 6. So the result obtained from the first integral is 2x cubed plus 9x squared y by 6, right? Now coming to the second integral. Integral of terms of n free from x into dy. Observe n. So we need the terms which are free from x. So 4y is a term which is free from x, right? So let's write 4y here. Because in the first term we are having x square which involves x. So we should not take the first term. We need a term which is free from x from n. So we are having 4y here. So take 4y equal to 4 integral y dy. This is equals to 4 into integral y dy is y square by 2. 2 2s are 4, which is equals to 2y square, right? So the result obtained from the second integral is 2y square. Now coming to the general solution to our problem. Therefore, the general solution is given by result obtained from the first integral is 2x cubed plus 9x square y by 6 plus result obtained from the second integral is 2y square equal to c, right? Now take the LCM of these two, or you can just write this as 2x cubed plus 9x square y plus 6 to the 12y square by 6 equal to c. Now take this 6 to RHS, then we'll get 2x cubed plus 9x square y plus 12y square equal to 6c. Since c being arbitrary constant and 6 is a constant, you can write 6c as some c, a constant. 6c equals to some c. Okay, then you'll get 2x cubed plus 9x square y plus 12y square equal to c, or we can write just as c. 2x cubed plus 9x square y plus 12y square equal to c. Therefore, 2x cubed plus 9x square y plus 12y square equal to c, or 2x cubed plus 9x square y plus 12y square equal to c is the required solution. This completes the problem. So we have seen a problem from differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.